Welcome to lecture number 2 in the UNC OBGYN Quality Improvement Toolbox lecture series. Today we're going to be talking about process maps. What are process maps? They're simply a tool for helping you visualize a complex process by drawing out all of the steps. Why would you want to do that? When you're doing a quality improvement project, taking the time to understand every single step in your process will help you figure out where things might be going wrong so that you can improve them. You will use a process map at 2 different points in your improvement project. The first is at the beginning to see how your process currently works. But then you'll use a process map again at the end to lay out the way that your process should work after you've improved it. Here is a very important point about making a process map, and I'll say this again later in our lecture. You must walk the process in person in order to make an accurate process map. You can create a first draft from memory and brainstorming with your team early in the project. But when you physically walk through the process in the location where it happens and talk to the people involved, you almost always find that it doesn't quite work the way you thought it did. And without taking the time to do this, you may miss important steps that could be targets for improvement, or you may find that certain steps that you thought happened either don't, or happen in a very different place or a different time than you thought they did. Let's take a look at a sample process we're all familiar with and build a very basic process map for it. Making breakfast. We start with our inputs, our ingredients, our plates, utensils, cookware. The process itself is going to be making breakfast, and then our outputs are going to be our finished ingredients. Making breakfast consists of 3 major steps: preparing our ingredients, cooking our ingredients, and serving those ingredients. But you can break down each one of those steps into sub-steps with more detail. We cook our bacon, then we cook our eggs, then we toast our bread, then we fry our potatoes. Then we want to delve even deeper, for instance, into cooking our eggs, and we can delineate individual detailed steps that make that process happen. We heat our pan, we pour our egg mixture in, stir it, add some pepper, and remove the cooked eggs. And each one of those cooking steps could be broken down into further sub-steps like that. When we're done, we have a very detailed map of how to make breakfast by looking at each individual steps that makes the process happen. This kind of rudimentary process mapping is okay for some very simple processes like making breakfast, but it doesn't always work for all of the different kinds of complex healthcare processes that we are going to be talking about. There are many different methods for process mapping out there. Some of them are specifically suited for manufacturing settings, some for IT or programming, some of them for organizational structure mapping. They all have one thing in common, and they each have specific symbols, and those symbols have particular meanings within the process map. Some simple methods use just a few symbols, like those you see below: squares, arrows, diamonds, circles, to delineate very basic kinds of steps. Others are much more complex, using many different symbols and colors, each of them having a very unique and specific meaning. Those kind of complex process mapping methods can take a long time to learn, and honestly, they're probably a lot more complex than what we need for the kinds of processes we're going to be studying. Many healthcare processes center around clinical assessments, each of which take into account a variety of data and result in one or more clinical actions. Now, you can adapt just about any kind of process mapping method to healthcare processes, and if you have a very simple process that you're studying, the basic linear form of process mapping that we saw with making breakfast might work for you. But I want to spend the rest of this lecture talking about a process mapping method that I helped to develop specifically for healthcare process mapping, and which can help you delineate the complex decisions and assessments that happen in clinical processes. We call this method gap process mapping for the 3 different types of symbols that compose it. We wanted to keep this method as simple as possible so that it would be easy to remember. So there are only 3 different symbols that we use in gap process mapping, and they correspond to the 3 basic types of action that you take in a clinical process. You gather clinical data in order to assess the clinical situation, and then you perform an indicated action. As you can see, the 3 different symbols correspond to a part of the letter from which they're drawn, and that should also help make it easier to remember what those symbols stand for. So let's look at a sample clinical process that we're all familiar with and build a process map for it. The management of labor and delivery on L&D is a complex web of many different processes, so we're going to focus on one particular part of that overall web of processes, that of evaluating a pregnant patient in triage for admission to labor and delivery. So let's look at how to build the L&D triage evaluation process map. Many clinical processes focus on an assessment of some kind. Therefore, it's helpful to start your process map with an assess step, which is your central clinical question. So we're going to start by naming our assess step that's at the core of our clinical question. In this case, the question is whether or not to admit the patient to labor and delivery. Now, when making the decision to admit or not, we take into account a variety of different factors, including maternal and fetal status, gestational age, prior pregnancy complications, vital signs, etc. So we need to gather all that data. Now, there are many different pieces of data that need to be gathered in order for us to make our central assessment. But we'll dig into those specific pieces later. For now, let's just organize them into general buckets or categories of data. We need things like OB history, the triage evaluation, and then guidelines that tell us when to admit and when to discharge. Once we've gathered our data and made our assessment, then we must perform an action. In the case of our example, we basically have three choices. If the patient doesn't meet admission criteria, we discharge them home. If they do, we admit them. But sometimes, when making a clinical assessment, you don't quite have enough information yet, and you need to gather more. So in that case, maybe we decide to walk the patient because we're unsure yet, so that we can gather more information and reassess later. This kind of loop is called a monitor loop. And when you're making process maps, you'll often see the need for essentially a holding pattern, for when things aren't quite yet clear and the clinical question needs to be reassessed at a later point with more information. So to review, the three symbols used in GAP process mapping correspond to gathering clinical data, assessing the clinical situation, and performing an indicated action. Now that we've learned the three main symbols used in GAP process mapping, and we've built a basic high-level overview of our process, let's go back and drill down into one of those buckets of data that we gathered at the beginning. Let's look particularly at the triage evaluation. We can break down that generalized bucket into sub-buckets of data that need to be collected in order to make our assessment. These series of nested buckets of data we call data compilations. Data compilations are basically a way to keep your overall process map simple and uncluttered, but still contain all of the information that you need to know your process in detail. The key to forming these nested series of gather steps is that each one should be thorough enough to include all of the relevant data that you need for your assessment, but filtered so that it doesn't include unnecessary pieces of data, which can clutter your map and clutter your assessment. In the example of our data compilation called triage evaluation, there are several sub-steps that compose that triage evaluation. We need to gather vitals, we need to do an exam, we need to gather labs, we need to monitor mom and baby. It's important when building your data compilations to specify the pieces of information that you would need in each one of those sub-gather steps. Now, it's important to note that you may not need every single one of these pieces of data for every single patient, but these are the most common ones that you need. And you can assume at least a basic clinical knowledge when you're making your process map. For instance, you know that you don't need a help panel and a UP2C for every single triage patient, but with a little bit of basic clinical knowledge, you know that you need those things for someone with an elevated blood pressure. Gather steps which are particularly complex or which are particularly critical to your process should be further broken down, in addition to just what data should be gathered. You can do that with what's called a gather in detail table, which delineates specific roles and responsibilities without cluttering up your main process map. It serves almost as an appendix for that particular gather step, separate from the main map, which provides detail when you want to drill down into the finest level of that step. Here is an example gather in detail table for our triage evaluation gather step. The first thing we want to do is delineate roles and responsibilities. Who is responsible for gathering what data? For instance, the physician is responsible for performing the exam, as well as interpreting the vitals, labs, and monitoring. The nurse, on the other hand, is responsible for gathering the vitals and the labs, as well as initiating the monitoring on the patient. Next, we need to fill in the specific pieces of data that we need to collect. I filled in some examples of important pieces of information to gather during a triage evaluation here. In your own process map, you'd want to take the time to be thorough and delineate all of the different pieces of information to be gathered here. It's important when filling out this table to also cite reference or normal ranges for these pieces of data so that you can make sure everyone's on the same page about how to interpret that data, as well as to specify where that data can be found so that everyone is clear. You can use a similar in-detail table to drill down into any assess or perform step in your process map. Let's look at an example of drilling down into our admission step. For example, you could break down our admit task like this. This perform in detail table groups the many different subtasks that need to happen to admit the patient by their overarching goal. With admitting a patient, for instance, the two separate goals are both to document the admission and then also to take the actions needed to get the patient into the hospital. So as I've documented these subtasks in this table, you'll note that I specified which particular care provider performs each one of the roles, and where any data that they might need to perform that subtask comes from. It's important to delineate who should be performing each one of the subtasks as part of our perform step, because then you make sure that all of the necessary components of the perform step are assigned to someone and they don't get dropped. Let's look at another example of a process map that was built for the MICU ventilator-associated pneumonia project that I mentioned in lecture number 1. This process starts by performing the action of intubating the patient. But then there are two central assess steps that must happen. One is assessing whether the patient is ready to extubate. The other is assessing whether or not the patient has pneumonia. Let's look at the bottom assess step first. You must gather a bucket of data to determine whether the patient's ready to extubate, and the team called that bucket of data their ventilator bundle. It's not important what goes into that right now, but just know that it's a data compilation like we saw in our prior example. Once making that assessment, if the patient's ready to extubate, great, you perform the step of extubating. But if the patient is not ready to extubate yet, then you'll see one of these monitor loops that we talked about, where the patient needs to be reassessed at a later date, and in the meantime, we're going to perform an action of optimizing that ventilator bundle. With our other assess step, assessing whether the patient has a pneumonia, there's another set of data that must be gathered for that, and they called that their lower respiratory infection, or LRI bundle. And again, it's not important what specific pieces of data went into that, only that it is a data compilation, which they further broke down into sub-buckets so that they could know what data to gather. If in assessing the patient it seemed unlikely that the patient had developed a pneumonia, again you see a monitor loop where they would then continue to reassess the patient for signs of a pneumonia while the patient was intubated. If it did seem likely that the patient was developing pneumonia, then you would perform the step of beginning the patient on empiric therapy. But there would be a simultaneous step that would also happen, which would be gathering some more information, specifically gathering data about cultures from a bronchoalveolar lavage. Once that data was gathered, that data would then feed into another assessment, which would be the assessment of sensitivities, so that then you could customize the therapy for the pneumonia based on those sensitivities. Similarly, they broke down some of their perform steps, for instance, optimizing that ventilator bundle with the kind of perform in detail tables that we saw before. And again, they organized the subtasks by the goal that those subtasks were trying to address. So you can see here some of the goals, subtasks, data that was needed, and roles that were performing those tasks. And this was actually a pretty detailed step, so they had 2 pages of goals, subtasks, data, and roles to specify who performed what data they would need, and what goal those tasks were addressing. By doing this, they were able to very specifically delineate roles and responsibilities for this very important perform step for preventing ventilator-associated pneumonias. Finally, let's review some characteristics that define a good GAP process map. First, as far as your gather steps are concerned, it's important to make your data compilations thorough yet filtered. It's also important to clearly describe in your in-detail table who gathers what data from where. With regard to your assessment steps, it's important to clearly define who uses what data to make the assessment. It's also important to build your process map in a way that accommodates clinical ambiguity. In other words, there's not always going to be just a yes or no answer to your assessment question. Sometimes you'll need, for instance, a monitor loop when the answer to your assessment is not yet clear and you need to perform a step in the meantime or gather more data, then reassess your question later. Finally, with regard to your perform steps, it's important that you appropriately include the entire clinical team and you define clear owners for every task so that things don't get dropped. So what now? It's time to meet with your class to map your process. In the email that's sent out with a link to this video, a PowerPoint was provided with some blank templates for you to use to map your process. You can also draw your process by hand if you find that easier, though for your final poster, it's probably helpful to use the graphics provided. And finally, you can start a draft of your process map from memory, but remember, it's important that someone from your team walks the process in person and talks to the care providers involved. If you skip this step, you'll almost certainly end up with a process map that doesn't accurately reflect how things work in real life, and you'll find it much harder to improve a process if you don't have it mapped properly. That's it for this lecture. Thank you for your time. And as you start to meet with your team to build your own process map, please feel free to contact me at any point with questions or problems.